Hello, and welcome to Sleepy Wiki. As you settle in, let your shoulders gently drop and allow your breathing to become slow and even. Tonight, we turn our gentle gaze towards something utterly fundamental, something that cradles life and whispers secrets older than time itself. Imagine the quiet gurgle of a hidden spring, or the vast, silent expanse of a deep ocean. This evening, we will simply drift through the essence of water, from the dewdrop glistening on a leaf at dawn to the immense power held within a distant cloud. Water has always been the great shapeshifter, the silent witness, the constant flow. It nourishes, it cleanses, it remembers. It is the very pulse of our world and, indeed, of ourselves. There's no need to strain or understand. Just let the words wash over you, like a gentle tide pulling back from the shore, allowing its calming nature to soothe your mind toward slumber. If these quiet journeys bring you comfort, a very gentle tap on the like button or a soft whisper of a subscription can help more sleepy minds find their way here. Now let us float on into the quiet, boundless world of water. The stars shimmer above, ancient and silent witnesses to our cosmic story. Tonight, as we drift deeper into the universe's embrace, let's cast our minds back not just millions but billions of years to a time when our Earth was a newborn, a world starkly different from the serene blue marble we cherish today. Imagine, if you will, the early Earth, not as a gentle cradle of life, but as a fiery, molten sphere, still glowing red from its furious birth. A world perpetually ablaze, constantly bombarded by stray rocks and planetesimals, a violent, chaotic place. In this inferno, water, as we know it, could not have existed. Any nascent moisture would have been vaporized instantly, banished to space by the sun's harsh glare or boiled away by the planet's internal heat. And yet, here we are, orbiting a sun, on a planet where oceans teem with life, where clouds drift across skies, and rain falls, nurturing every living thing. So, the profound question arises, a cosmic riddle whispered across the eons. Where did all this water come from? How did our thirsty planet quench its primordial thirst? For a long time, scientists pondered this mystery, like detectives piecing together clues from an ancient crime scene. The prevailing theory, beautifully elegant in its simplicity, suggests that Earth's water was not born with the planet itself, but rather delivered from the far reaches of our solar system, arriving on cosmic express trains of ice and rock. Picture the early solar system, a vast swirling disk of dust and gas, much like a cosmic potter's wheel. Close to the young sun, where temperatures soared, only rocky materials could condense. This region became the birthplace of planets like Mercury, Venus, Earth, and Mars. Further out, beyond what scientists call the frost line or snow line, temperatures plummeted. Here, volatile compounds like water ice could also condense alongside rock and metal, forming icy planetesimals, the building blocks of the gas giants and countless smaller, frozen worlds. It's from this distant, icy frontier that our water journey begins. Imagine these ancient messengers hurtling through the nascent solar system. Two main candidates emerge in our cosmic tale: comets and asteroids. Comets, often called dirty snowballs or cosmic snowmen, are spectacular wanderers. They originate from the very edges of our solar system, the Kuiper Belt, beyond Neptune, or the even more distant Oort cloud, a vast icy shell surrounding our sun. These celestial bodies are essentially frozen reservoirs of water ice, dust, and other volatile compounds, remnants from the solar system's chaotic youth. When a comet's orbit is perturbed, perhaps by the gravitational tug of a giant planet or a passing star, it can be flung inward toward the sun, trailing its magnificent tail as its ice vaporizes. For years, comets were the prime suspects for Earth's water delivery. It seemed logical. They are mostly ice, and there were billions of them. A cosmic deluge of cometary impacts raining down upon the early Earth could certainly have filled our oceans. However, science, like a good detective, constantly refines its theories with new evidence. As we develop the technology to study comets up close, sending probes like Rosetta to rendezvous with them and analyzing their composition, a curious discrepancy emerged. Scientists measure the ratio of deuterium, a heavier isotope of hydrogen, sometimes called heavy hydrogen, to regular hydrogen, DH ratio, in water molecules. This ratio is like a cosmic fingerprint, a unique signature that varies depending on where the water formed in the solar system. When we measured the DH ratio in water from many comets, particularly those from the distant Oort cloud, we found that their water often had a significantly higher DH ratio than the water found in Earth's oceans. It was like finding a suspect with the wrong shoe size, a mismatch. While some comets, like Rosetta's target 67P Churyumov-Gerasimenko, did show a higher ratio, others, notably Jupiter family comets like Hartley 2, exhibited a DH ratio closer to Earth's. This suggested that while some comets might have contributed, they might not be the sole or even primary source. So, the cosmic detectives turned their gaze towards the second group of suspects: asteroids. Not all asteroids are dry, rocky bodies. A specific type, known as carbonaceous chondrites, are ancient, primitive asteroids that formed further out in the solar system, beyond the frost line, but not as far as the comets. These rocky messengers are rich in carbon and contain significant amounts of water locked up in their mineral structures, like tiny sponges soaking up cosmic moisture. When we studied the DH ratio in water extracted from meteorites that originated from carbonaceous chondrite asteroids, a fascinating pattern emerged. Their deuterium to hydrogen ratio was a remarkably good match for Earth's ocean water. It was like finding the exact fingerprint. This suggested that a significant portion, perhaps the majority of Earth's water, was delivered by these water-rich asteroids during a period of intense bombardment, known as the Late Heavy Bombardment, occurring roughly 4 to 3.8 billion years ago. Imagine these asteroids not just as dry rocks, but as cosmic cargo ships, carrying precious cargo of water within their stony matrix. They weren't just splashing water onto Earth, they were delivering it in a form that could survive the fiery impact, slowly releasing their trapped moisture as the Earth cooled. The story gets even more intricate. The migration of gas giants like Jupiter and Saturn in the early solar system played a crucial role. Their immense gravitational pull would have stirred up the asteroid belt, sending a torrent of these water-rich carbonaceous chondrites careening inward, some on a collision course with our young Earth. It was a chaotic, violent time, but one that was essential for our planet to become the vibrant, watery world it is today. So, as you can see, our oceans are not just pools of earthly water. They are vast, ancient collections of cosmic water delivered from the depths of space, a testament to the incredible journey of our planet. Each drop carries within it the echoes of distant asteroids, the whispers of primordial comets, and the grand gravitational dance of our early solar system. It's a humbling thought, isn't it? That the very essence of our planet, the source of all life, traveled billions of miles across the cosmos, patiently waiting for the right moment to quench our Earth's thirst. This journey from fire to water is just one chapter in the magnificent saga of our planet, a tale of creation and cosmic collaboration. And as we continue to explore the universe, we uncover more and more about the unique properties of this miraculous substance that made our home so special. Once delivered to Earth, this clear, unassuming liquid had to prove itself worthy of cradling life. Beneath its tranquil surface lie secrets woven into the very fabric of its being, secrets that begin with an incredibly unique molecular structure. Toilon. The journey into water's gentle magic begins with a tiny, invisible architect, the water molecule itself. Imagine, if you will, a miniature, ethereal boomerang, or perhaps a tiny bent whisper in the vast quiet of the universe. This is H2O, two humble hydrogen atoms politely holding hands with one more substantial oxygen atom. But it's not a straight line, like three pearls on a necklace. Oh no. The oxygen atom sits at the gentle curve of the bend, like the center of a very delicate V shape, with each hydrogen atom at the tips. This isn't an arbitrary design. It's a masterstroke of cosmic engineering. The oxygen atom, you see, is a bit of a gentle magnet when it comes to electrons, those tiny energetic particles that buzz around atoms. It has a slightly stronger pull than its hydrogen companions. Think of it like a very polite tug of war, where oxygen gently coaxes the shared electrons a little closer to its own embrace. This subtle lean creates an imbalance, a gentle asymmetry. The oxygen end of our little boomerang becomes ever so slightly negative, carrying a whisper of an extra electron cloud. And, as a natural consequence, the hydrogen ends, having their electrons drawn slightly away, become ever so slightly positive. This delicate unevenness is what scientists call polarity. Our water molecule is now a tiny, invisible magnet with a positive side and a negative side, like a miniature, perfectly balanced battery. It's this polarity, this gentle magnetic personality, that unlocks water's most profound abilities. Because water molecules are these tiny bent magnets, they can't help but be drawn to one another. The slightly positive hydrogen end of one water molecule is irresistibly, yet gently, attracted to the slightly negative oxygen end of a neighboring water molecule. It's not a full-on, unbreakable bond like the ones within the molecule, but rather a soft, ephemeral embrace, a delicate handshake, or a fleeting dance partners gracefully turning. We call these elegant connections hydrogen bonds. Imagine a vast, invisible network of these gentle handshakes, stretching out in all directions. Billions upon billions of water molecules, each holding hands with several others, forming a constantly shifting, fluid tapestry. It's these hydrogen bonds, these countless tiny attractions, that give water its extraordinary character and make it the life giver we know. One of the most apparent gifts of these hydrogen bonds is something called cohesion. This is water's delightful tendency to stick to itself. Picture a tiny, invisible ballet where each water molecule is gently holding on to its neighbor. This cohesive strength is what allows a drop of water to hold its rounded shape on a leaf, or why an insect can seem to walk on the surface of a pond, as if on an invisible trampoline. The collective strength of those hydrogen bonds creates a remarkable skin on the water's surface, a delicate tension that resists being broken. It's like a soft, elastic membrane, allowing a tiny water strider to glide effortlessly without sinking, supported by the united front of countless water molecules beneath its delicate feet. Without this gentle cohesion, water would simply spread out into a thin, featureless film, unable to form droplets, unable to gather in ponds, unable to flow as rivers. But water doesn't just stick to itself. It also possesses adhesion, a gentle longing to cling to other surfaces. Think of the way dew drops sparkle on a blade of grass, or how water creeps up the narrow stem of a plant, defying gravity. This is adhesion at play. The water molecules, with their positive and negative ends, are drawn to the slightly charged surfaces of other materials, gently climbing upwards. This combined power of cohesion and adhesion is responsible for capillary action, a vital process for all life on Earth. It's how trees, those silent giants, can draw water from their roots hundreds of feet into the sky against the pull of gravity. Each water molecule, through its delicate hydrogen bonds, pulls the next one up, like an endless chain of tiny, determined climbers ascending an invisible ladder fueled by the gentle tug of both itself and the plant's tiny vessels. The hydrogen bonds also gift water with a remarkable ability to regulate temperature. This is its high specific heat capacity. Imagine water as a very patient guardian, a natural thermostat for our planet. Because each water molecule is gently holding on to its neighbors with those hydrogen bonds, it takes a lot of energy, a surprising amount of warmth, to make them jiggle and vibrate fast enough to break those bonds and significantly raise water's temperature. It's like trying to get a crowd of gently linked dancers to suddenly sprint. It requires a lot more effort than if they were all independent. This means that oceans and large bodies of water absorb vast amounts of heat during the day, preventing extreme temperature spikes, and slowly release that heat at night, keeping coastal regions milder. It's a profound influence on our climate, smoothing out the sun's fiery kiss and the night's cool embrace, making life possible in so many places. Similarly, these bonds are responsible for water's high heat of vaporization. To turn liquid water into a gas, to make it evaporate and rise into the sky as mist or clouds, even more energy is needed. Not just enough to make the molecules vibrate faster, but enough to completely break those gentle hydrogen bonds, allowing them to escape as individual, free-floating gas molecules. This property is crucial for how living things cool themselves. when we sweat, or when plants transpire, the evaporation of water carries away a significant amount of heat from our bodies, helping us to maintain a stable internal temperature. It's nature's exquisitely designed cooling system, all thanks to those persistent, gentle hydrogen bonds. Perhaps one of water's most astonishing tricks, however, is its behavior when it freezes. Most substances become denser when they turn solid, shrinking as their molecules pack more tightly together. But not water. As liquid water cools, its molecules slow down, and those gentle hydrogen bonds begin to lock into a more rigid, open, crystal-like structure. Picture them not just holding hands, but arranging themselves into a delicate, sprawling ballroom dance, each dancer needing a little more space than when they were simply mingling. This elegant, open lattice structure of ice means that the water molecules are actually further apart than they are in liquid water. Consequently, solid ice is less dense than liquid water, which is why ice floats. Think of the profound implications of this seemingly simple fact. If ice sank, our lakes and oceans would freeze solid from the bottom up, trapping and killing aquatic life and making the thawing of spring a rare and devastating event. Instead, a protective layer of ice forms on the surface, insulating the water below and allowing life to continue thriving beneath its frozen lid. It's a fundamental aspect of Earth's biology, a winter's gentle blanket born from the unique geometry of the water molecule and the graceful embrace of its hydrogen bonds. Finally, water is famously known as the universal solvent. And once again, our tiny polar boomerang molecule is the star of the show. Because water has those slightly positive hydrogen ends and that slightly negative oxygen end, it's exquisitely adept at interacting with other molecules that also have charges, or partial charges. When a substance like salt, sodium chloride, dissolves in water, the water molecules surround the individual sodium and chloride ions, their charged ends gently tugging them apart and pulling them into solution. It's like a welcoming party, where the water molecules gracefully embrace the newcomers, isolating them and holding them in their fluid embrace. This ability to dissolve so many different substances, nutrients, minerals, gases, is utterly essential for life. It allows our blood to transport vital chemicals, plants to draw up minerals from the soil, and countless chemical reactions to occur within living cells. Water, in its quiet, unassuming way, becomes the grand stage upon which the drama of life unfolds, all thanks to its unique ability to host and mingle. So, as you can see, this simple molecule, H2O, with its bent shape and its gentle magnetic personality, is anything but simple. It's a master of disguise, a patient guardian, a life-sustaining architect, all due to the elegant dance of its hydrogen bonds. These tiny, invisible forces shape our world in ways we often don't perceive, from the dew on a spider web to the vast currents of the ocean to the very beating of our hearts. And with that understanding of water's foundational structure, we can now gently drift towards another of its marvelous properties, equally essential for life's grand tapestry: how it interacts with the light of our sun. But water molecules don't stay still. follow a single drop as it embarks on its grandest adventure, a ballet performed on a planetary stage. Imagine, if you will, a single drop of water, perhaps resting serenely in the vast embrace of the ocean or twinkling on a dew-kissed leaf. This little traveler is about to embark on an incredible journey, one that touches every corner of our world, a journey we call the global water cycle. The first act of this cosmic dance begins with an invitation from the sun. Our sun, that distant, gentle artist, warms the surface of our planet. Its golden touch doesn't just bring light. It provides the essential energy that coaxes water from its familiar liquid form into an invisible gas, water vapor. This magical transformation is called evaporation. Think of it as water quietly shedding its visible form, becoming light enough to rise, to literally float away. From the shimmering expanse of our magnificent oceans, where billions upon billions of water molecules dance under the sun, evaporation lifts incredible volumes of water into the atmosphere. But it's not just the oceans. Lakes, ponds, rivers, any body of open water contributes to this ethereal rise. Even the damp soil, after a refreshing rain, breathes water vapor into the air. And then there are the silent, steadfast forests. Through tiny pores on their leaves, trees release water vapor into the atmosphere in a process known as transpiration. It's like the earth itself is breathing, exhaling its moisture upwards. Together, evaporation from open water and transpiration from plants are often combined and referred to as evapotranspiration. Each day, unfathomable quantities of water embark on this upward journey, rising, like tiny, invisible wishes ascending to the sky, a crucial part of our planet's energy transfer system. As these invisible water vapor molecules ascend higher and higher, the air around them grows cooler. It's a bit like climbing a tall mountain. The higher you go, the crisper and colder the air becomes. In this cooler upper atmosphere, these individual water molecules begin to huddle together. They lose some of the energy that allowed them to float freely, and they start to cling to microscopic dust particles, pollen or sea salt crystals floating in the air, tiny nuclei around which they can gather. This gathering, this gentle embracing, is called condensation. It's the moment when the invisible becomes visible again. These tiny, newly formed liquid water droplets, or sometimes ice crystals in very cold conditions, are so incredibly small and light that they can remain suspended in the air. And when enough of these droplets or crystals gather together, swirling and swaying, what do we see? Clouds, fluffy, wispy, towering, or stretched like painted strokes across the sky. Each cloud is a visible testament to condensation, a temporary home for countless water travelers drifting on the unseen currents of the wind. These cloud communities drift across the sky, carried by whispers of the wind, until they reach a point where they can no longer hold their precious cargo. The tiny water droplets or ice crystals within them continue to collide and merge, growing larger and heavier. Eventually, gravity, that ever-present conductor, calls them home. They become too heavy to remain suspended, and they begin their descent back to Earth. This return journey, the falling of water from the atmosphere, is precipitation. Most commonly, we know it as rain, a gentle patter or a drumming deluge depending on the intensity. But depending on the temperature within the cloud and below it, precipitation can take many forms. Soft, intricate snowflakes, each one a unique crystal, tiny, icy pellets of sleet, or even the dramatic, sometimes thunderous, chunks of hail. Each form is a different expression of water's journey back to the ground, a vital delivery that replenishes our world, a gift from the sky that nourishes every living thing. Once these water travelers have completed their aerial descent, they find themselves back on solid ground. Here their paths diverge once more, a multitude of choices laid before them. Some drops might land on a high mountain peak, perhaps joining a blanket of snow that will slowly melt. Then they'll begin to trickle down slopes, joining other drops to form tiny rivulets. These rivulets grow into streams, and streams merge into mighty rivers, carving their way across the landscape, shaping canyons and fertile valleys. This flow of water over the land surface, guided by gravity's steady hand, is known as surface runoff. It's like the land's own intricate circulatory system, gathering water from every contour and guiding it towards larger bodies of water, eventually leading back to the grand, waiting oceans. But not all water hurries along the surface. Many drops, upon meeting the soft embrace of permeable soil or porous rock, begin to seep downwards. This process, where water enters the ground, is called infiltration. Imagine water patiently finding its way through countless tiny pathways, through grains of sand, particles of clay, and cracks in rock, moving deeper and deeper. This water that has infiltrated the soil can then continue to move downwards, a process called percolation, through layers of rock and sediment until it reaches an underground reservoir. Here, in the silent, hidden depths, it becomes groundwater, a vast, unseen ocean beneath our feet, filling the spaces between rock particles and within cracks in bedrock. This groundwater can remain stored for centuries, slowly moving through the earth, eventually emerging as a spring, or feeding into rivers and lakes, or even directly back into the ocean, completing another segment of its immense journey. It's a hidden, slow dance, a quiet persistence that reminds us of the many secret lives water leads, unseen but profoundly vital. And so, this journey is not a sprint, but a perpetual, ongoing cycle. Water doesn't just move, it also rests, sometimes for brief moments, sometimes for millennia. The largest reservoirs of water on Earth are, of course, our magnificent oceans, holding about 97% of all our planet's water. But water also finds temporary homes in glaciers and ice caps, those vast frozen libraries of ancient water that can store it for thousands, even hundreds of thousands of years. Lakes and rivers are dynamic, though shorter-term storage facilities, their waters constantly refreshed. Even the soil holds water, known as soil moisture, vital for plant life. And, as we've discussed, the atmosphere itself is a temporary, fleeting reservoir for water vapor, holding it for perhaps a few hours or a few days before it condenses and falls. Our own bodies, too, are tiny, living reservoirs, reminding us of our deep, intimate connection to this precious substance. This constant movement and temporary storage in various reservoirs is what makes the water cycle so dynamic and fundamental to life. At the heart of this ceaseless ballet is the sun's energy. It is the sun that powers the evaporation, lifting water against gravity, initiating the entire grand tour. And it is gravity that eventually brings it back down, guiding it through rivers and into the ground. This beautiful, intricate dance ensures that water is constantly recycled and redistributed across the planet, moving between its liquid, solid, and gaseous states, shaping landscapes, nourishing ecosystems, and sustaining every living thing. It's essentially a closed system, meaning the same water molecules have been circulating for billions of years, merely changing form and location, an eternal, life-giving loop. As we close our eyes and imagine this incredible journey, we begin to appreciate the silent, tireless work of water all around us and within us. It's a cycle that seems to manage itself with such elegant precision, an ancient rhythm woven into the very fabric of our world. But sometimes, even this grand self-regulating system feels the subtle touch of other forces that can alter its tempo, change its currents, or even redirect its flow. And as we continue our gentle exploration, we'll turn our thoughts to understanding these influences, to the delicate balance that defines water's role in our changing climate. And so, as we drift deeper into the quiet wonder of water, let us consider the truly extraordinary. For within every single drop, within every shimmering wave, there are unseen forces at play. A hidden choreography of tiny particles that grants water its most magical and life-sustaining qualities. It's a story whispered by the very fabric of our world, a lullaby of the fundamental. And imagine, if you will, the tiniest building blocks of water, individual molecules, each a delicate union of two hydrogen atoms clinging to one oxygen atom. But these aren't just any atoms, they have a secret. The oxygen atom, you see, is a little bit like a friendly, yet slightly dominant magnet. It pulls the shared electrons, those tiny, energetic dancers, a little closer to itself. This leaves the oxygen end of the molecule with a faint, gentle negative charge, while the two hydrogen ends become ever so slightly positive. We call this peculiar arrangement polarity, like a tiny, perfectly balanced battery with a positive side and a negative side. Now here's where the unseen magic truly begins. Because these water molecules are polar, they are irresistibly drawn to each other, like tiny, courteous dancers holding hands across a ballroom. The slightly positive hydrogen of one molecule reaches out to the slightly negative oxygen of another, forming what scientists call hydrogen bonds. These aren't strong, unbreakable chains. Rather, they are like delicate, invisible threads, constantly forming, breaking, and reforming. Think of them as soft, fleeting embraces, allowing water molecules to cling to one another with a gentle but persistent affection. It is these countless, ephemeral hydrogen bonds that bestow upon water its most remarkable characteristics. One of the most enchanting results of these unseen bonds is what we call cohesion. It's the tendency of water molecules to stick to themselves. You see it in a dewdrop clinging perfectly round to a spider web, or the way raindrops bead up on a leaf, holding their form against gravity. Those tiny, invisible handshakes between water molecules create a kind of delicate, invisible skin on the surface of water, which we call surface tension. It's strong enough to allow a tiny water strider to glide effortlessly across a pond, or for a carefully placed paper clip to float, defying what our eyes tell us should happen. This cohesion also allows water to be pulled upwards as a continuous stream, like an unseen rope when you draw it through a straw. But water isn't just good at sticking to itself. It's also a master of adhesion, the ability to stick to other things. If a surface also happens to have positive or negative charges, even slight ones, water's polar nature means it will readily form those same gentle hydrogen bonds with it. This is why water climbs up the inside of a narrow glass tube, or why a paper towel soaks up a spill. It's called capillary action, and it's a vital, unseen force that allows trees to draw water from their roots all the way to their highest leaves, defying gravity itself, molecule by molecule, step by tiny, adhesive step. Then there's water's incredible ability to manage temperature. Imagine a thermal blanket for the entire planet. Water has a remarkably high specific heat capacity, which means it can absorb a great deal of heat energy before its own temperature rises significantly, and likewise, it can release a lot of heat before cooling down much. Those hydrogen bonds, those gentle embraces we spoke of, require a surprising amount of energy to stretch and break apart. This is why vast oceans act as colossal thermostats, moderating the Earth's climate, making coastal regions milder than inland areas. It's also why our own bodies, which are mostly water, maintain a steady temperature, even when the air around us changes. Water acts as a patient, steady guardian against sudden thermal shocks. Building on this, water also possesses a high latent heat of vaporization. This means it takes an enormous amount of energy to transform liquid water into a gas, like steam. Think of it as water taking a deep, slow breath of heat energy before it can finally float away into the air. This property is crucial for cooling. When you sweat, the tiny droplets of water on your skin absorb a large amount of heat energy from your body as they evaporate, carrying that heat away and leaving you feeling refreshed. It's a beautifully efficient, unseen cooling system, essential for many living things. Perhaps one of the most astonishing of water's unique traits is its behavior when it freezes. Unlike almost every other substance on Earth, water becomes less dense as a solid than as a liquid. At around 4 degrees Celsius, water molecules are at their most compact. But as the temperature drops further towards freezing, those hydrogen bonds become more rigid, locking the molecules into an open crystalline structure, like an intricate, airy lattice. This means that ice, instead of sinking, floats. Picture icebergs majestically riding the ocean currents, or a layer of ice forming on top of a frozen lake. This floating layer acts as a natural insulator, protecting the aquatic life beneath from the harsh cold above. Without this peculiar property, lakes and oceans would freeze solid from the bottom up, making life as we know it vastly different, if not impossible. And finally, consider water as the ultimate explorer, the universal solvent. Because of its polarity, water can gently pull apart and dissolve many other substances, especially those that are also polar or ionic, like salts and sugars. Its tiny, charged ends are perfectly designed to embrace and surround individual molecules or ions of other compounds, effectively dissolving them. This is why water is so vital for life. It can carry dissolved nutrients through our bloodstreams, transport minerals in the soil to plant roots, and endlessly reshape the very geology of our planet, gradually dissolving mountains one molecule at a time. It's a constant, gentle force, of transformation. So, as you picture a quiet stream, a gentle rain, or a glass of water by your bedside, remember these unseen forces, these delicate bonds, these hidden properties. They are the silent architects of our world, shaping climates and sustaining life in ways both seen and unseen. These properties do more than shape the physical world. Inside every leaf, every cell, every part of your own body, water performs an even more intimate role as life's master key, unlocking the potential for all biological processes. These aren't static places. They are dynamic, ever-changing realms where countless tiny components must move, interact, and transform. And at the heart of this ceaseless activity, providing the perfect stage for the drama of life, is water. Water, in its silent, pervasive presence, acts as life's master key, unlocking the potential for all biological processes. It is more than just a liquid. It is the ultimate biological solvent, a remarkable medium that allows the myriad molecules of life to dance, interact, and build the structures we know. Think of it as the great cosmic conductor, ensuring that all the instruments in the orchestra of life are in tune and ready to play. But what gives water this extraordinary power? What is its secret? The answer lies in its unique molecular structure, a story of delicate balance and powerful attraction. Each tiny water molecule, H2O, is like a miniature, perfectly balanced magnet. It has 2 hydrogen atoms nestled close to 1 oxygen atom. Now, oxygen, being a bit of a gentle giant in this tiny world, has a slightly stronger pull on the shared electrons, drawing them a little closer to itself. This isn't a full tug-of-war victory, but more of a gentle lean, creating a slight, almost imperceptible imbalance in the molecule's charge. The oxygen end becomes ever so slightly negative, while the hydrogen ends become ever so slightly positive. This seemingly small detail, this polarity, is the true magic of water. Imagine each water molecule as a tiny, skilled dancer with a slightly charged hand reaching out. These little dancers are constantly moving, reaching, and forming gentle, flexible handshakes with their neighbors. These handshakes are what we call hydrogen bonds. They're not as strong as the bonds within a water molecule, but they are numerous and constantly forming and breaking, allowing water molecules to cling to each other and, crucially, to many other types of molecules. It's this constant, gentle clasping and unclasping, this continuous fluid embrace, that makes water such an incredible solvent. It's a liquid that is always ready to welcome and interact. Consider the substances that are vital for life: salts, sugars, proteins, even the very building blocks of our genetic code, DNA. These are the water lovers, or hydrophilic molecules, from the Greek words meaning water-loving. When a water-loving substance, like a pinch of salt, dissolves, something beautiful happens. A salt crystal is made of positive sodium ions and negative chloride ions, held tightly together. But when they meet water, those tiny polar water molecules spring into action. The slightly negative oxygen ends of water molecules are drawn to the positive sodium ions, gently surrounding them. At the same time, the slightly positive hydrogen ends of other water molecules cluster around the negative chloride ions. It's like a welcoming committee, each water molecule taking an ion by the hand, gently pulling it away from the crystal and cradling it within the liquid. The salt crystal, once a solid structure, is now dispersed, its ions free to move and participate in life's processes. This same embracing dance happens with other vital molecules. Sugar molecules, with their many oxygen and hydrogen atoms, are also polar, and water molecules eagerly form hydrogen bonds with them, dissolving them completely. Proteins, the complex workhorses of our cells, fold into their intricate shapes largely because of their interactions with water. Even our DNA, the blueprint of life, is hydrophilic, allowing its crucial information to be accessible and functional within the aqueous environment of our cells. Without water's ability to dissolve and suspend these molecules, they would remain locked away, unable to perform their essential roles. This dissolving power is not just about making things disappear, it's about making them available. Think of your blood, a bustling river of life, mostly water. It carries oxygen from your lungs to every cell, transports nutrients from your digestive system, and whisks away waste products to be eliminated. In plants, the sap, rich in dissolved sugars and minerals, flows upward against gravity, nourishing every leaf and blossom. Within every single cell, water acts as a universal transport system, a microscopic freeway for molecules, ensuring everything is where it needs to be, precisely when it's needed. Furthermore, many of life's most important chemical reactions, the ones that sustain us and allow us to grow and think, literally take place in water. It's the ultimate reaction chamber. Molecules, once dissolved, can freely bump into each other, react, and form new substances. Water isn't just a bystander, it's often a participant, sometimes being split apart to provide hydrogen or oxygen for a reaction, or being formed as a byproduct itself. It's the silent matchmaker, bringing the right molecular partners together for the dance of chemical transformation. But not everything in life is a water lover. There are also hydrophobic substances, the water-fearing ones, like fats and oils. These molecules are non-polar, meaning they don't have those gentle charged ends that water molecules do. When they encounter water, the water molecules, with their strong desire to form hydrogen bonds with each other, actually push the non-polar molecules away. It's not an act of rejection, but rather water's preference for its own company, creating an almost exclusive club. This seemingly simple repulsion is incredibly important. It's why oil and water separate, but it's also the fundamental principle behind cell membranes. These vital barriers, made of fatty molecules, create the enclosed spaces of cells, holding the watery inner world separate from the watery outer world. Without water's tendency to push these fats together, the very boundaries that define life couldn't exist. So, from the smallest ion drifting in your bloodstream to the intricate folding of a protein, water's unique properties as a solvent orchestrate the vast, complex symphony of life. It's not merely a medium. It's an active, indispensable participant, enabling transport, facilitating reactions, and even shaping the very structures that define us. The life we know, in all its astonishing complexity and delicate balance, is truly a testament to the quiet power of water, the biological solvent. From the smallest ion drifting in your bloodstream to the intricate folding of a protein, water's unique properties orchestrate the vast, complex symphony of life. Its gentle currents carry the breath of life, allowing the world to awaken and unfold. Yet this life-giving substance, so abundant in our cells and streams, faces a paradox on the planetary scale. Imagine our Earth as a breathtaking sapphire, suspended in the velvet dark of space. From afar, it is a marble of brilliant blues, greens, and whites, so undeniably a water world. Indeed, approximately 71% of our planet's surface is covered by water, a liquid embrace that makes life as we know it possible. Yet, beneath this awe-inspiring spectacle lies a delicate truth, a whisper carried on the wind. Not all water is equally accessible, nor equally abundant in its usable form. This is where the story of water as a critical global resource truly begins to unfold, like an ancient map guiding us through hidden valleys and towering peaks of understanding. Of all that magnificent blue you see from space, a surprising, almost poignant fact emerges. Only a mere fraction, a precious approximately 2.5 to 3% of all Earth's water, is fresh. Think of it like this. If all the water on our planet were to fill a large bathtub, the amount of fresh water available would barely fill a single, small thimble. It's a tiny sip from an ocean of blue, yet it is this thimbleful that sustains nearly all terrestrial life. And even within that small thimble of fresh water, most of it is held in frozen embrace, locked away in the majestic sleeping giants of our planet, glaciers and polar ice caps. Roughly 68.7% of all fresh water is nestled here, glittering in the high mountains or spreading across the poles in vast, silent expanses. They are nature's grand reservoirs, slowly releasing their ancient stores, but also, as we've come to understand, vulnerable to the warming whispers of our changing climate. Below our feet, hidden from direct view, lies another substantial portion of this vital liquid, groundwater. Around 30.1% of our fresh water resides here, flowing slowly through subterranean aquifers, like vast, unseen rivers, threading through the Earth's porous bones. It's a silent journey, often undisturbed for centuries, a hidden wellspring accessed through patient drilling, providing a steady supply for many communities, a lifeline beneath the surface. And finally, the water we see and often interact with most, the lakes, the rivers, the wetlands, accounts for a mere 1.2% of all fresh water. These are the surface jewels, the meandering veins that carry life through landscapes, reflecting the sky and nourishing everything they touch. This uneven distribution, this delicate balance, paints a picture of water as a truly finite and precious gift. It's the lifeblood of our planet, the silent architect of civilizations. Consider how deeply intertwined our daily lives are with its presence. Think of the food on our tables. Agriculture alone accounts for approximately 70% of global freshwater withdrawals. From the grains that form our bread to the fruits that sweeten our days, each bite carries the invisible imprint of water, a vast network of irrigation and rain sustaining the fields. It's a silent partnership between sun, soil, and water, yielding the very sustenance that fuels us. Then there's industry, the whirring gears and complex processes that shape our modern world. Approximately 20% of fresh water is utilized here, cooling power plants, manufacturing goods, and cleaning materials. Water is not merely a tool, it's an essential component, a medium of transformation, allowing the intricate dance of production to continue. And in our homes, for drinking, cooking, cleaning, and hygiene, we use the remaining approximately 10%. This is the water that directly touches our lives. The gentle flow from the tap, the comforting steam from a kettle, the cleansing rush of a shower. These numbers, while seemingly abstract, tell a profound story of our collective reliance, a quiet testament to water's indispensable role. However, this deep reliance, combined with the uneven distribution, gives rise to a critical challenge: water scarcity. It's a complex tapestry woven from various threads. Sometimes it's a physical scarcity, simply not enough water in a particular region to meet the demands of its population and ecosystems, leading to parched lands and dwindling reservoirs. Other times, it's an economic scarcity, where water might exist in sufficient quantities, but the infrastructure, resources, or management systems to access, treat, and distribute it safely and efficiently are simply not there. Imagine a river flowing nearby, yet the wells are dry, not due to lack of water, but due to lack of means to draw it forth. This leads to untold hardship, to long journeys for a single bucket of water, a burden that disproportionately falls upon the most vulnerable among us. The global tapestry of water is further complicated by the subtle yet profound shifts brought about by climate change. We feel its effects in the altering rhythm of the planet's breath. Melting glaciers, those ancient freshwater banks, contribute to rising sea levels, but paradoxically, their rapid retreat also threatens the long-term water supply for millions who depend on their seasonal meltwater for agriculture and drinking. Precipitation patterns are becoming more erratic. Some regions face prolonged scorching droughts, turning fertile lands to dust, while others contend with devastating floods, overwhelming rivers, and washing away homes. These are not just distant news stories, they are the shifting reality for communities across the globe, a constant renegotiation with the very source of life. And it's not just about the quantity of water, its quality is equally vital. The clear, pristine nature of water can be easily tarnished. Pollution, a silent, creeping shadow, enters our waterways from various sources: agricultural runoff carrying fertilizers and pesticides, industrial discharge laden with chemicals, and untreated sewage. These contaminants render water unfit for drinking, harmful to ecosystems, and a threat to human health. When a river is burdened with pollutants, its life-giving properties diminish, affecting everything from the smallest aquatic creature to the largest city that relies on its flow. Water truly knows no borders. Rivers flow across nations. Aquifers stretch beneath continents. This shared ownership demands a spirit of cooperation, a recognition that the well-being of one community is often inextricably linked to the stewardship of another, perhaps thousands of miles away. Understanding our collective water footprint, the total volume of fresh water used to produce the goods and services consumed by an individual or community, including the invisible virtual water embedded in our food and products, helps us grasp the global scale of our impact. So as we consider water as a critical global resource, we see it not just as a commodity, but as a fundamental human right, an ecological necessity, and a shared inheritance. Its sustainable management is one of humanity's most pressing challenges and greatest opportunities. It calls for ingenuity, for technologies like efficient irrigation and advanced wastewater treatment, for the promise of desalination, though often energy-intensive, and, most importantly, for mindful conservation in every home, every farm, every factory. Tonight, as you drift towards sleep, let the gentle thought of water wash over you. Its incredible power, its quiet generosity, its vital role in every breath we take. May we all hold this precious blue liquid with the reverence it deserves. Imagine, if you will, looking out across a boundless expanse, a shimmering canvas stretching further than the eye can see, meeting the sky at a distant, hazy line. This isn't just a view. It's a silent guardian, a colossal engine working tirelessly to maintain the delicate balance of our planet. We're talking, of course, about our Earth's vast oceans, those magnificent bodies of water that cover more than 70% of our world's surface. Tonight, let's drift gently into understanding how these deep, enigmatic waters act as Earth's primary climate regulator, a grand conductor orchestrating the planet's temperature, its breath, and its very mood. It's a story of profound interconnectedness, where the smallest ripple and the deepest current play a vital role in the comfort of our world. Think of our oceans not merely as immense reservoirs, but as the Earth's very own thermal battery, a colossal living blanket that absorbs, stores, and redistributes the sun's energy. Sunlight, warm and insistent, strikes our planet, and much of it falls upon the ocean's surface. Unlike land, which heats up and cools down relatively quickly, water has an extraordinary capacity to absorb a tremendous amount of heat without a significant rise in its own temperature. This property, known as high heat capacity, means the oceans can soak up vast quantities of solar radiation, far more than our continents, preventing the land from becoming unbearably hot during the day and frigidly cold at night. It's like a patient, gentle giant, evening out the extremes, offering a steadying hand to our planetary thermostat. The warmth absorbed by the ocean doesn't just stay put. It begins a grand, slow journey. Here, we encounter the ocean's intricate network of currents, the silent, powerful rivers that flow within the sea. These currents are like an intricate, unseen dance, a slow-motion ballet of colossal scale, constantly rearranging the planet's warmth. Picture a global conveyor belt, operating deep beneath the surface and across vast stretches of the open ocean. This is the thermohaline circulation, often called the Great Ocean Conveyor Belt, driven by differences in temperature, thermo, and salinity. Haline, warm, less salty water from the tropics, flows towards the poles, releasing its heat into the atmosphere, warming coastal regions and moderating climates in places that would otherwise be much colder. As this water cools and becomes denser, and as ice formation at the poles increases its salinity, it sinks to the abyss and begins a slow, deep journey back towards the equator, eventually rising to the surface to complete its cycle. It's a continuous, millennia-long loop that ensures the sun's warmth is distributed equitably around the globe, preventing some areas from becoming scorching deserts, while others freeze solid. Consider the familiar warmth of the Gulf Stream, a powerful current that originates in the Gulf of Mexico and brings tropical heat across the Atlantic. making places like Western Europe significantly milder than other regions at similar latitudes. Without this oceanic embrace, many of the world's populated coastlines would be profoundly different, dramatically colder, and far less hospitable. The ocean, through these immense aquatic rivers, is constantly in motion, sharing its absorbed warmth, ensuring that life can flourish far beyond the sun-drenched equator. But the ocean's role as Earth's climate regulator extends far beyond merely managing heat. Our oceans also breathe, not with lungs of tissue, but with the boundless surface that meets the sky, absorbing an astonishing amount of atmospheric carbon dioxide. Imagine the ocean as a colossal sponge, drawing in a significant portion of the CO2 that we release into the atmosphere. This makes the ocean a vital carbon sink, a natural buffer against the buildup of greenhouse gases. When carbon dioxide dissolves from the air into seawater, it undergoes chemical reactions, forming carbonic acid and other compounds. But the ocean's capacity to absorb CO2 isn't solely a chemical process. It's deeply entwined with life itself. Billions upon billions of microscopic organisms, known as phytoplankton, drift near the ocean's surface. These tiny plant-like creatures are like the ocean's very own mini-forests, performing photosynthesis, using sunlight to convert carbon dioxide and water into energy, releasing oxygen in the process. They are the base of the marine food web, and their insatiable appetite for carbon dioxide helps to draw vast amounts of this greenhouse gas out of the atmosphere. When these phytoplankton eventually die, some of their carbon-rich remains sink to the deep ocean, effectively locking away carbon for centuries, perhaps even millennia, in what's known as the biological carbon pump. It's a silent, ceaseless ballet between air and water, chemistry and biology, working in concert to keep our atmosphere's carbon levels in check. And let's not forget the ocean's profound connection to the global water cycle. The sun's energy not only warms the ocean, but also causes evaporation, turning liquid water into vapor that rises into the atmosphere. This isn't just a local phenomenon. It's the primary source of atmospheric moisture, feeding the clouds that form over land and sea, eventually returning as rain or snow. These clouds, born from the ocean's gentle exhalations, also play a role in climate regulation, reflecting sunlight back into space and helping to cool the Earth. Without the ocean's endless giving of water vapor, our continents would be parched, and the intricate dance of precipitation, so vital for all terrestrial life, would cease. The sheer volume of the world's oceans also grants them an incredible thermal inertia. This means that they warm up and cool down very slowly. Imagine a massive, dense object. It takes a lot of energy to get it moving, and once it's in motion, it takes a lot of energy to stop it. Similarly, the ocean doesn't rush into decisions. It contemplates, it holds, it remembers. Its vastness gives it a kind of thermal memory, smoothing out temperature fluctuations over long periods. This slow response acts as a natural stabilizer, preventing abrupt and extreme climate shifts, offering a crucial buffer against rapid environmental changes. It gives our planet, and all life on it, time to adapt. a steady anchor in the ever-changing currents of our climate. From the tiny phytoplankton that form the foundation of life and absorb carbon, to the monumental currents that distribute warmth across continents, to the vast, slow-breathing body of water that dampens temperature extremes, the ocean truly is the silent, beating heart of Earth's climate system. Its processes are interwoven, complex, and vital, a testament to the elegant self-regulation of our blue planet. From the tiny phytoplankton that form the foundation of life and absorb carbon, to the monumental currents that distribute warmth across continents, to the vast, slow-breathing body of water that dampens temperature extremes, the ocean truly is the silent, beating heart of Earth's climate system. As we journey through the vast, shimmering realm of water, it's easy to imagine it as an endless bounty, a boundless blue on our planet's surface. But as the evening stars begin to pepper the sky, let us gently consider a delicate truth. The fresh water we depend on is a precious, finite treasure, a mere whisper amidst the ocean's roar. Picture our Earth, a magnificent blue marble swirling in cosmic dust. Most of that captivating blue, over 97.5%, is salt water, a briny embrace that sustains an incredible array of marine life but isn't readily available for human needs. Of the remaining 2.5% that is fresh water, the vast majority, nearly 70%, is locked away, serene and silent, in the majestic ice caps and glaciers of the polar regions and deep beneath our feet in ancient aquifers. A much smaller fraction dances in our rivers and lakes, weaves through our soil, or floats as vapor in the sky. It's a truly tiny sip from a colossal cup, a shimmering jewel that requires our deepest care and understanding. And it is this precious sip, this vital essence of life, that we are called upon to protect and manage with wisdom. For gentle listeners, as our global family grows and our ways of life evolve, this delicate balance is facing increasing pressures. We find ourselves at a moment where the freshwater crisis, though often unseen like the quiet roots of a tree, demands our thoughtful attention. Imagine the intricate veins of a leaf carrying life-giving sap. Our rivers and aquifers are much the same for the land, but they are increasingly strained. Population growth naturally means more thirsty people, more farms to feed them, and more industries to support our societies. Alongside this burgeoning demand, the shifting patterns of our climate bring longer, more intense droughts in some regions, leaving fields parched and reservoirs dwindling, while in others, fierce floods overwhelm water systems with too much water, too fast, often carrying pollutants into our precious sources. Then there's the quiet intrusion of pollution itself, the unseen chemicals from industry, the runoff from agricultural lands, and domestic waste, all subtly blurring the purity of water, making it unusable without extensive and often costly treatment. This delicate tapestry of challenge asks for our ingenuity and our compassion. But fear not, for humanity's spirit of innovation and cooperation shines brightest when faced with such profound challenges. We are not without solutions. Rather, we are embarking on a beautiful journey of rediscovery, learning to respect and cherish every drop. Our first and most fundamental step, much like tending to a beloved garden, is conservation. This is about making every drop count, mending the leaks in our precious vessel. In our homes, this means fixing that persistent drip from a faucet, which over a year can quietly waste thousands of liters. It's choosing water-efficient appliances like washing machines that sip water rather than guzzle it. In the vast fields where our food grows, ancient practices are being reimagined with modern science. Instead of irrigating whole fields where much water is lost to evaporation, technologies like drip irrigation deliver water directly to the roots of each plant through tiny, precisely placed tubes. It's like a plant receiving a personalized, gentle drink, minimizing waste and maximizing efficiency. Farmers are also using smart sensors in the soil, which tell them exactly when and how much water is needed rather than guessing. Even industries, those great engines of our economy, are finding ways to recycle processed water, treating and reusing it within their own systems, transforming waste into resource. It's a collective act of mindful stewardship, ensuring no drop is forgotten. Beyond careful usage, we are also learning to give water a second and even a third life through water recycling and reclamation. Think of a graceful dance where water completes its journey, is transformed, and then returns to the stage. Modern wastewater treatment plants are no longer just about cleaning water enough to return it to a river. They are becoming sophisticated purification temples. Using advanced multi-stage filtration, membrane technologies like reverse osmosis, and powerful UV disinfection, treated wastewater can be purified to standards suitable for a variety of uses, from irrigating parks and golf courses to supplementing industrial processes, and in some pioneering cities, even being purified to a potable standard, ready to rejoin the drinking water supply. This closed-loop system, often called the urban water cycle, is a testament to our ability to reimagine and redefine our relationship with what we once considered waste. It's a powerful affirmation that water, once used, is not gone, but merely on a different stage of its grand journey, awaiting its rebirth. Then, there's the truly transformative science of desalination, a process that unveils the sweetness hidden within the ocean's vast, salty embrace. It's like a patient alchemist, extracting liquid diamonds from the seemingly endless sea. The most common method, reverse osmosis, works by gently pushing salt water through incredibly fine, semi-permeable membranes at high pressure. These membranes are like microscopic sieves, allowing the pure water molecules to pass through while leaving the larger salt molecules behind. It's an elegant physical separation, transforming the undrinkable into the life-giving. Other methods, like thermal distillation, mimic the natural water cycle, heating salt water until it vaporizes, leaving salts behind, and then condensing the pure steam back into liquid. While desalination is energy-intensive, technological advancements are constantly making it more efficient, and the integration of renewable energy sources like solar and wind power is beginning to chart a path towards more sustainable production of fresh water, offering a vital lifeline to arid coastal regions around the world. But our solutions don't always need to be grand feats of engineering. Sometimes they are as simple and elegant as rainwater harvesting. Imagine gently cupping your hands to collect falling blessings from the sky. This age-old practice is finding new relevance today, from simple barrels collecting water from rooftops for garden use to larger cisterns integrated into building designs for flushing toilets, or even, with proper treatment, supplementing drinking water. Rainwater harvesting reduces our reliance on municipal supplies and eases the strain on natural ecosystems. Furthermore, we are deepening our understanding of sustainable water management and the protection of natural ecosystems. Wetlands, for instance, are not just beautiful habitats. They are nature's own incredible water filters, purifying water as it flows through them. Forests and healthy watersheds act like sponges, slowing down rainwater runoff, allowing it to seep into the ground and recharge aquifers rather than rushing away. By protecting these natural infrastructure assets, we help the Earth regulate and purify its own water systems. It's a holistic approach, recognizing that we are part of a larger, interconnected web. Ultimately, addressing the global freshwater crisis is a symphony of efforts, each instrument playing its part. It involves the quiet vigilance of individuals conserving water at home, the dedicated work of scientists and engineers devising new technologies, and the thoughtful collaboration of communities and nations. Advanced technologies like AI-powered sensors are now being deployed to detect leaks in vast underground pipe networks that stretch for thousands of kilometers, preventing billions of liters of water from being silently lost. Smart water grids are emerging, optimizing distribution and predicting demand. International agreements are fostering cooperation for shared river basins, acknowledging that water flows across borders, nourishing all it touches. It is a testament to our collective capacity for wisdom, for innovation, and for working together to safeguard this most essential element of life. As the world outside quiets and you drift deeper into peaceful slumber, remember that every challenge holds the seed of a solution, and that water, in all its forms, continues its magnificent, life-sustaining dance. Yet even our most ingenious solutions face a new test. The Earth itself is a vast living tapestry, intricately woven with threads of land, air, and water. For eons, this tapestry has held a delicate balance. But now, as our global climate shifts like a slow-motion dance, this balance is being nudged, transforming the very nature of how we find, use, and cherish our water. The whispers of a changing climate are felt keenly by our planet's water cycle, that grand, unending journey of evaporation, condensation, precipitation, and flow. One of the most poignant tales it tells is of the world's frozen giants, the glaciers and ice caps. Tucked away in the high mountains or vast polar regions, these ancient reservoirs have acted as natural, slow-release water towers for millennia, holding vast quantities of fresh water in their icy embrace. But as our world warms, even by a few degrees, these giants begin to weep faster, their solid forms transforming into liquid torrents too quickly. This accelerated melting not only contributes to global sea level rise, but also disrupts the steady, seasonal flow of rivers that millions depend on for drinking, agriculture, and industry. Picture a magnificent age-old clock, suddenly sped up, its hands spinning wildly. That's the rhythm of these melting ice giants. Initially, this might seem like an abundance of water, but it's a fleeting bounty, often leading to devastating floods in the short term, followed by crippling water shortages when the source eventually dwindles. Then there's the sky itself, our greatest and most unpredictable provider. Climate change is teaching it new, more extreme behaviors. The gentle, consistent rain that once nourished our fields is becoming a memory in some regions, replaced by prolonged periods of dry stillness. The earth, parched and thirsty, cracks under the relentless sun, and the vibrant greens of life fade into desperate browns. These aren't just dry spells. They are extended droughts, more intense and far-reaching than before, leaving communities and ecosystems gasping. Conversely, in other places, the sky's generosity turns into an overwhelming deluge. Instead of gentle showers, we see furious, concentrated downpours, shedding an entire season's worth of rain in a matter of hours or days. Our rivers swell beyond their banks, our towns become temporary lakes, and the land, unable to absorb such a sudden onslaught, suffers devastating floods. It's as if the sky has forgotten how to sprinkle, only knowing how to withhold or unleash a waterfall. Even the silent, invisible realms beneath our feet are affected. Along our coasts, where the land meets the ocean in a timeless embrace, a subtle yet profound struggle unfolds. As global temperatures climb, not only do glaciers melt, but the ocean water itself expands, a phenomenon known as thermal expansion. This leads to sea level rise, and with it, a creeping danger for our vital freshwater reserves. Imagine a hidden network of underground rivers, our precious aquifers, holding clean, sweet water for us. As the ocean rises, its salty tongue can intrude into these freshwater pockets, pushing the salt deeper into the land, rendering wells undrinkable. This is called saline intrusion, and it's a quiet but potent threat, especially for coastal communities and their agricultural lands. The very warmth in the air also plays a role, escalating evaporation rates from surface reservoirs and soils, literally drawing moisture up and away faster than ever before, further intensifying droughts. Faced with such a monumental challenge to the very essence of life, humanity must respond not with fear, but with ingenuity, cooperation, and a deep respect for water. This is where the concept of water management in a changing climate truly comes into its own. It's about more than just finding new sources. It's about fundamentally rethinking our relationship with water. One of the cornerstones of this new relationship is water conservation and efficiency. Think of every drop as a precious jewel not to be wasted. This means adopting smart technologies in our homes, like low-flow fixtures that whisper instead of gush, or smart irrigation systems that listen to the soil's needs, watering only when and where it's truly required. In industries, it means redesigning processes to reuse water multiple times, turning a linear flow into a circular dance. Every saved drop is a drop that doesn't need to be found, pumped, or treated, reducing both our environmental footprint and our energy consumption. Then there's the realm of innovative solutions, where science offers new possibilities. Consider desalination, the intricate process of gently coaxing the salt from ocean water, transforming the vast, undrinkable sea into a potential source of fresh water. While energy-intensive, advancements are continuously making it more efficient and sustainable. And equally fascinating is wastewater recycling, where used water, through sophisticated purification processes, is transformed and given a second life. Imagine water that once went down a drain, now returned to the tap, clean and safe, having completed a remarkable journey of renewal. It's a testament to our ability to turn waste into resource. But sometimes, the oldest wisdom is the best. Nature itself provides exquisite blueprints for water management. This leads us to green infrastructure. Instead of simply paving over everything and shunting rainwater away, we can design our cities to drink the rain. Think of permeable pavements that allow water to soak into the earth, replenishing underground aquifers, rain gardens that capture and filter stormwater runoff, preventing floods and pollution, or rooftop gardens that absorb rain, cool buildings, and create urban oases. These natural solutions mimic the sponge-like quality of forests, allowing water to slowly infiltrate the ground, preventing both immediate flooding and long-term drought. Crucially, managing water in a changing climate demands a holistic perspective, a grand orchestra where every instrument plays in harmony. This is the essence of Integrated Water Resource Management, IWWRM. It's about seeing water not as isolated rivers or lakes, but as a connected system, from the cloud that releases the rain, through the forests that absorb it, to the rivers that carry it, and the aquifers that store it. It involves all stakeholders, communities, farmers, industries, environmentalists, and governments, working together, making decisions that consider the social, economic, and environmental impacts across entire river basins. It's about collective stewardship, recognizing that every action upstream affects those downstream. Finally, we must build for resilience. Our infrastructure, designed for a more predictable past, must be adapted for an uncertain future. This means investing in climate-resilient infrastructure, building dams that can handle more variable flows, designing stormwater systems capable of managing heavier, more frequent downpours, and strengthening our levees and coastal defenses against rising sea levels and storm surges. It also includes projects for managed aquifer recharge, where surplus surface water is intentionally directed into underground aquifers during wet periods, creating strategic underground storage that minimizes evaporation and provides a buffer against drought. As we gently navigate these shifting waters, understanding and implementing these thoughtful strategies become paramount. The story of water, like all great stories, continues to unfold, and we are now, more than ever, its careful and conscious co-authors. And as we ponder these intricate systems of our blue planet, let's turn our gaze now to another fascinating cycle, one that also relies heavily on the presence and movement of water. Our journey now leads to a horizon shimmering with promise, the future, where human ingenuity, guided by a deep reverence for this precious resource, reshapes our relationship with water, ensuring its gentle flow for generations yet to come. It's a story not of scarcity, but of innovation, a symphony of solutions orchestrated by science and stewardship. Imagine, if you will, a world where the very definition of waste water begins to fade, replaced by the understanding of a resource in continuous circulation. One of the most significant chapters in this future tale involves advanced water treatment and reuse technologies. Our current methods are good, but the future holds even greater refinement. Picture an urban landscape where every drop that leaves a home or industry is not merely discharged, but carefully collected, guided through a series of elegant purification steps. These might include multi-stage filtration systems, capable of capturing even microscopic particles, or biological processes, where tiny, dedicated microorganisms consume pollutants, transforming them into harmless byproducts. Further along, ultraviolet light and ozone treatments act as final, silent guardians, neutralizing any remaining whispers of unwanted elements, ensuring the water emerging is sparklingly clean, often purer than the water we initially drew from natural sources. This isn't just a dream. It's a rapidly evolving reality where cities are embracing a circular water economy, transforming effluent into a valuable source for irrigation, industrial processes, and potentially direct potable use, thus closing the water loop. But the ocean, that vast, enigmatic blue, holds an even grander promise. For millennia, its salty embrace has kept its waters beyond our reach for direct consumption. Yet, within its depths, lies an almost infinite supply. The future of desalination technology is quietly revolutionary. Beyond today's energy-intensive reverse osmosis, scientists are unfurling new sails. Imagine membranes so incredibly fine, often created with nanotechnology. They can distinguish a single salt molecule from the life-giving water, almost like a bouncer at a microscopic club, letting only the purest guests through. Consider also forward osmosis, a gentler, more natural pull, where a highly concentrated plowed draw solution plus literally sips fresh water through a semi-permeable membrane, leaving the salt behind, requiring less brute force and energy. And even more wondrous is the field of biomimicry. Nature, in its boundless wisdom, has already perfected many of these processes. Think of the tiny aquaporin proteins within our own bodies, creating water channels that are incredibly efficient. Scientists are now learning from these miniature master architects, designing synthetic membranes that mimic their elegance, allowing water to flow freely while leaving impurities behind, much like a perfectly designed sieve. These future desalination plants will be quieter, more energy efficient, and capable of turning the ocean's vastness into a gentle, drinkable stream without leaving a heavy footprint. As our world becomes more interconnected, so too must our approach to water management. Enter the era of smart water networks, a silent, digital symphony orchestrating the flow of life's essential fluid. Picture a city's water infrastructure not as a static map of pipes, but as a living, breathing entity, constantly monitored by an invisible network of digital guardians. Tiny sensors, like vigilant sentinels, are embedded throughout the system, listening for the faintest whisper of a leak, detecting subtle changes in pressure or flow that signal a problem long before it becomes visible. These sensors feed data to powerful artificial intelligence, AI, and machine learning algorithms that act like wise conductors, analyzing patterns, predicting demand, and optimizing the distribution of water. This means less water lost to leaky pipes, a staggering amount in many current systems, and more efficient delivery to where it's needed most. We're even seeing the rise of digital twins, virtual replicas of entire water systems that allow engineers to simulate changes, test solutions, and predict outcomes without disturbing the real-world infrastructure, making our water networks robust, resilient, and remarkably responsive. It's like giving our water systems a digital brain, always learning, always optimizing. But what if we could gather water from the very air around us, like catching whispers from the sky? This brings us to the fascinating realm of atmospheric water generation, AWG. In many regions, the air holds a surprising amount of moisture, even if it doesn't feel humid. Imagine structures designed to harvest fog, like colossal, delicate nets stretched across misty landscapes, condensing droplets into a gentle trickle. Or consider innovative devices, some no bigger than a small appliance, that can efficiently extract water vapor from the air, using clever refrigeration cycles or advanced desiccants to draw out the hidden moisture, transforming the unseen into a tangible, drinkable resource. These technologies are particularly promising for remote areas or emergency situations, offering a decentralized, independent source of fresh water, a comforting alternative to distant pipelines or trucking. This is a future where the sky itself becomes a gentle wellspring. And speaking of collecting nature's fleeting gifts, the future will see a much wider adoption of rainwater harvesting and greywater recycling within our homes and communities. Imagine every roof becoming a catchment basin, guiding pure rainwater into storage tanks for gardening, flushing toilets, or even, with appropriate treatment, for indoor use. Similarly, greywater systems will gently reclaim water from sinks, showers, and washing machines, diverting it for non-potable uses, significantly reducing our overall demand for freshly treated water. These aren't just minor adjustments. They represent a fundamental shift in how we view and manage water within our own personal spheres, transforming every home into a miniature water management facility. Yet, technology alone is not the sole architect of this water-rich future. Nature itself, our oldest and wisest teacher, offers profound solutions. Nature-based solutions are gaining recognition as powerful, sustainable approaches to water management. Think of constructed wetlands, not just as beautiful landscapes, but as living filters, where plants and microbes work in harmony to purify stormwater runoff or treated wastewater, returning it to the environment cleaner than before. Consider green roofs and permeable pavements. In our cities, designed to absorb rainfall, reduce urban flooding, and allow water to slowly seep back into the ground, recharging our vital underground aquifers rather than overwhelming storm drains. Restoring natural riverbanks, planting forests strategically, and protecting watersheds are all acts of stewardship that enhance nature's own capacity to purify, store, and regulate water flow. It's about working with nature, not against it, understanding that the most resilient water systems are often those that mimic the Earth's own elegant designs. And ultimately, the future of water is not just about groundbreaking technology, it's also about a deeper, collective shift in human consciousness. It's about fostering a culture of water stewardship, where every individual understands their role in protecting this shared resource. Education, policy, and community engagement will weave together with technological advancements to create a tapestry of conservation. From innovative agricultural practices that minimize water usage, to industrial processes that embrace closed-loop systems, to the simple, mindful choices we make in our daily lives. Every action creates a ripple. These advancements, these visions of a water-secure future, are not isolated islands of innovation. They are interconnected, forming a grand symphony where each part plays a crucial role. From the depths of the ocean to the whispers in the sky, from the quiet hum of a smart sensor to the gentle rustle of a wetland, the future holds the promise of abundance, carefully managed and deeply respected. As the world outside begins to hush, Drawing the gentle curtain of twilight across the sky, let us take a final soft breath together, reflecting on the marvelous silent journey of water. Not a journey of grand, loud declarations, but one of patient, persistent whispers, a quiet dance that has unfolded since time began and continues even now, all around us and within us. Imagine for a moment the vast, timeless sweep of its story. We've touched upon how it rises, unseen and ethereal, from the vast open ocean, drawn upwards by the sun's warm, soft kiss, transforming into an invisible vapor, a silent ascent, carried on the gentle currents of the air, becoming the very breath of the sky. Then, in the cool, distant heights, it gathers, coalescing into the softest, fluffiest clouds, like dreams taking shape against the blue canvas of day or the velvet darkness of night. It doesn't rush, it simply is, allowing itself to be carried, to transform, to prepare for its next quiet act. And when the moment is right, it returns, sometimes as a whisper of mist, painting the morning world with a pearly sheen, clinging to spider webs like tiny, shimmering jewels, sometimes as the soft, insistent patter of rain on your window pane, a lullaby against the roof, nourishing the thirsty earth below with 1,000 gentle kisses. Or perhaps it descends as the feathery caress of snowflakes, each a tiny, intricate wonder, drifting down to blanket the world in a serene, muffling quiet, inviting us to contemplate the stillness. From the sky, it flows, a tiny, glittering dewdrop on a leaf, slowly merging with others, finding its path. A gentle trickle joining a playful stream, winding its way through mossy banks, singing a quiet, rippling song to the pebbles. Each drop, each stream, contributes to a larger, more profound movement, always finding its way downwards ever so patiently towards the waiting embrace of a river. And eventually, the boundless, deep peace of the ocean once more. It is a journey of reunion, a return to the source, only to begin anew, without end, without question. Think of the sheer, quiet wonder of this cycle. Water never truly leaves us. It merely changes its costume, its form, its fleeting address. From the vast expanse of a lake, reflecting the stars above like a shimmering mirror, to the cool, deep current beneath the earth, hidden from our sight, it is always there. It is the lifeblood of every tree, the hidden pulse in every flower, the gentle moisture in the soil that cradles tiny seeds, promising future growth. It is the essence of every living thing, a constant, reassuring presence, shaping our world with its soft, persistent power. And it is within you, too, a quiet, moving stream, an inner ocean connecting you to every drop that has ever fallen, every cloud that has ever drifted, every river that has ever flowed. You are a part of this ancient, ongoing story, a vessel for this extraordinary, ordinary wonder. There is such comfort in knowing that this same water has seen millennia, has witnessed the unfolding of life, has cleansed, refreshed, and sustained countless generations. It carries within it a deep, silent wisdom, a testament to endurance, adaptability, and the profound beauty of simply being. as you settle deeper into your pillow and the soft darkness gathers around you. Take this thought with you. The journey of water is one of endless calm, relentless gentleness, and boundless patience. It teaches us that even in constant movement, there is profound peace. Even in transformation, there is unwavering identity. It is a promise whispered on the breeze, a reassurance carried on the quiet current, that all things return, all things find their path, and all things are interconnected in a grand, harmonious ballet. So close your eyes now. Feel the gentle weight of your own body, the quiet rhythm of your breath. Let your thoughts drift soft and slow, like clouds across the night sky, or dewdrops settling on a leaf. And as you fall into the soft embrace of sleep, know that water's quiet, wondrous journey continues. Perhaps in your dreams tonight, you will become a part of it. A drop of rain, a shimmering river, a boundless ocean, moving with effortless grace, experiencing the endless calm of its cycle. Rest well, knowing that this beautiful, gentle journey never truly ends, but simply pauses for now to continue in the peaceful currents of your deepest dreams. Sweet dreams, little scientist. Good night.